Hello everyone and welcome back to the channel. Today we have a review and it is an inverter from Leesky. I believe it's a 2000 watt pure sine wave inverter. So let's go ahead and open it up and check it out. So let's see what we got. Okay. Nice thick styrofoam right on top. Looks like we have a small user manual. All right, we also have some cable to connect to the battery, and looks like we have a grounding cable as well. So I've never seen an inverter come with a grounding cable. That's kind of nice. Let's see, on this side we have a remote. So there's a remote in here. All right, and here is the inverter. Okay, let's go ahead and take it out of this bag. All right, first impressions. It's a fairly good size. I like how big it is. Like if we compare this to a 1500 watt inverter, here's the alpha inverter right here. So you're talking it's a good 5 inches longer. And it's 2 inches wider. So it's a fairly good size. All right, it feels like it's all aluminum casing. It says 2000 watts right here, continuous power. Over here it says model LS 2000 SAR from Leesky. Input is 12 volts. Output is 110 to 120 volts at 60 hertz. It has USB outputs. They are 5 volts at 2.4 amps. And it does say that it's a pure sine wave inverter. Let's see, there's nothing over here except for 4 screws. On the bottom, there's a California Proposition 65 warning. And then there are other warnings that just say to prevent electric shock, fire, serious injury, your standard warnings for an inverter. Looks like on this side there's actually even more screws. That's a lot of screws. Let's see, on the back there are 2 fans, and then there's the positive and negative connections. And these connections do come with washers, lock washers, or split washers, however you want to say it, and a nut. And then on this side, we have our remote connection. We have an on-off button right here. We have a protection light and a power light. We have our 2 USB connections. And we have a GFCI outlet right here. So this is very interesting to me. This is the first inverter that I've ever reviewed that's actually had a GFCI outlet on it. And then again on the top it does have a screen right here. So let's go ahead and connect it to a battery and see what this screen says. Okay, so let's go ahead and connect up this inverter. The one thing I noticed, I was going to go ahead and just use the cables that came with it. One side is for the inverter, so it's fitted for the inverter, so it fits on there perfectly. But the other side, these ringlets are pretty big. They're almost too big for these M8 bolts that are on this battery. This is just a little 50 amp battery from Timeusb. And I was just going to use this just to turn it on and see what the screen said. Because I have another battery in mine that's actually going to use this to test. And I hope that they're not too big for all these connections. But let's go ahead and connect it up. And these cables that came with it, they are stamped with 16 millimeters squared. It's 2 16 millimeter squared cables, 600 volts. and they are rated for 105 degrees Celsius. All right. Yep, they fit on this 50 amp battery just fine. So they're okay. All right, and you always want to tighten these down so they do not move. Because if they move, they can arc. And if they arc, that's where fires begin. Next thing I'm going to do is I'm going to go ahead and just put this resistor on the negative. So that way I can pre-charge the capacitors in the inverter so there's not a spark. And the one thing I notice about this inverter is there's no switch. There's no like power switch on here. It's a button. So I don't know if it's on or off. I'm guessing that it's if it's disconnected from the battery, it's probably always in an off state, but we'll find that out. So let's go ahead and connect our resistor real quick. Charge up those capacitors. And now connect it, and no spark. It's exactly the way it should be. Let's go ahead and turn it on. See what we get. Okay. There we go. You have to hold the button down for about a second before it turns on. Here is what the screen looks like, and that is actually nice and clear. I like that. That's nice. Shows that our battery is at 13.3 volts. It shows that it's a full battery. I'm guessing that is judging on the voltage of the battery. It does show a symbol right here that's, I'm guessing that just shows that it's pure sine wave. We'll test that in a second. That shows the load. That might show like the load capacity, so we'll kind of be looking at that. The output is on, it looks like, because the battery, this little thing, it shows an output on. The voltage, it shows a voltage of AC. It shows 122 volts at 60 hertz, and it shows that there is 0 watts in the output. So a nice, simple screen, but it tells you plenty of really good information. It also comes with this remote, and it's a pretty basic remote. So let's go ahead and take this off. Let's go ahead and plug in the remote. Okay, and the remote lights up as soon as you turn it on. It shows the pretty much the percentage of the battery, which is kind of nice. I'm guessing it just matches whatever this shows. It does show a power button. There is an on-off button, and there's also a red fault light. So if we press this on-off button, it does turn off the remote, or it turns off the inverter like it should. And then you got to hold it down. There we go. And it turns it right back on, and everything resets to the on position. So very simple remote, but it does exactly what you need. It turns it on and off. It tells you your battery status, and it tells you if it has any faults. So let's go ahead and unplug that. We're not going to be really using this, but a nice little addition. Okay, I was looking at the specifications on the manual. The model I have is the 12 volt LS2000 SAR. It's a 2000 watt inverter with a 4000 watt peak. Let's see, like I said, it's 110 to 120 volts. You can also get the 220 or the 240 volts. It's 50 hertz or 60 hertz. It does say that it's pure sine wave. The efficiency, it says about 90%. Overheat protection is 149 plus or minus 41 degrees Fahrenheit. And then the overload protection is going to be between 2,000 and 2,400 watts. It does have short circuit protection. The screen is LCD. It has two USBs. No load current. The 12 volt is a 2.2 amp, so it uses 2.2 amps on standby. So what, about 24 and a half watts, something like that? It says the cooling fans, they will not turn on until it reaches a temperature above 104 degrees Fahrenheit, or the load exceeds 40%. So if it goes over 85 or 850 or 900 watts, the fans should turn on. Operating temperature is 0 degrees Celsius or 32 degrees Fahrenheit to 104 degrees Fahrenheit. Storage temperature is 14 degrees Fahrenheit to 113 degrees Fahrenheit. The size is 443 millimeters by 203 millimeters, and the height is 100 millimeters. And it weighs right under 5 kilograms. So that'd be right around 12 pounds. One thing I do notice in this manual, here is the LS2000 SAR. That is the model that I have. And it does show that the front screen has the USB ports, the remote control interface, and the power switch. It has the AC outlets and the grounding, but it also does say that it has AC hardwire. And this one does not have that. It does not have the AC hardwire. It instead has the GFCI plug. So I feel like they may need to either make separate manuals if there is another option that's like this. That way people aren't confused when they look at this and they think that they're getting some sort of AC hardwire. So just so you know, Leesky, you should probably make sure that your manual matches what your inverter actually is, if it's going to be the exact same model number. Okay, so let's go ahead and get some measurements out of this. Let's make sure that the voltage AC is correct. So we got our multimeter here. Let's go ahead and plug it into the AC outlet. All right, 121.3, so that is pretty close. I just wanted to show you the GFCI outlet. There is a test button and a reset button. So if you hit the test, there is a green light that shows that the outlet is on. You hit the test, turns it off. Press that down to reset it. If we take our multimeter and we put it on continuity, if we go our line, if we go our neutral to ground, we do have continuity. But if you go your line to ground, the GFCI automatically pops. So it works exactly the way that it should. And I just want to let you know that I am the worst when it comes to the proper terminology. So please leave it in the comments if I say the wrong thing, because I just do that and I cannot stop myself. So please leave in the comments if you notice anything I'm saying is of the wrong terminology. All right, I got my pure sine wave little monitor on here, my oscilloscope, and it does show a nice clean sine wave. So it definitely is pure sine. Okay, the next thing that we're gonna do is we're gonna see how accurate this display is right here. So we are going to be plugging in probably like a 400 watt load, just because, again, for test purposes, I just have this little 50 amp battery. And you really only should push about 600 watts in this battery before it could start freaking out. So we're gonna go ahead and just do like a 400 watt load, and we will look at this, and we will look at a like a kilowatt as well, and we'll see the difference on that. Okay, and for this test, let's go ahead. I have it plugged into a little 2 foot long extension cord, and then plugged into this monitor. And with this monitor, you can't see it very well. This is the worst. It's stupid. All right. Oh, there you go. Okay, you can see that. Let me make sure it turns off. I just wanted to show you that the voltage on this monitor shows 121.2, and over here it shows 121. So they are practically exact. But what we care about is the wattage. Okay, and what we're going to plug in is we're going to plug in this halogen lamp right here, and I believe that it pulls right around 400 watts. So let's go ahead and plug it in and see what happens. Okay, plugging it in. And I don't know if you can see that, but that says 420, pretty much 430 watts, yeah, let's just say 430 watts. And down here, it is showing 400 watts. So there is a discrepancy. Let's look at that. Yeah, so this is, the monitor on the right is showing 431, but the output on the inverter shows 400. So let's go ahead and calculate on the DC side to see how many watts are coming directly out of the battery. And you do that by multiplying the amperage coming from these cables to the inverter by the voltage of the battery. So let's go ahead and figure that out now. Okay, so the DC voltage on the battery is 12.48, and on the monitor, on this monitor right here, it shows 12.3. So it's a little lower than what the battery is actually reading. Let's see what it says at the terminals. Yeah, 12.4. So it's pretty close. It's off by 1/10 of a volt. That's not terrible. But let's find out. So let's just say 12.4, and let's figure out the amperage. Zero it out. 12.4 times 38.4. 38.4 equals, and that is 476 watts. So there's 476 watts coming straight out of the battery. The AC side says that there's 431 watts going into that light. So if you subtract 476 by 431, you get, let's see, minus 431, you get 45 watts of loss. Okay, and in the manual it did say that that the fans will kick on if the output is over 40%, which is what, around 800 to 900 watts, because you got to think 1,000 watts would be 50%. So let's just say 900 watts. So let's go ahead and plug in at least 900 watts to make sure those fans actually kick on. And we know that this halogen lamp is already 400 watts. So I've got a heat gun here. We're going to go ahead and plug that in, and we will put it on, we'll just put it on low, but that should probably give us 1,000 watts. So let's try it. All right, plugging in the heat gun. Put it on low. It only says 580 watts. So let's go ahead and kick this on high. Yes. Now we got 1,440 watts on this display. And the fans did kick on. And as soon as it gets below 900 watts, those fans automatically kick off. So that little programming does work when it comes to the fans. Okay, now that we tested a few things on this inverter, I would like to maybe stress test it a little bit. And the best way that I can think of doing that is I'm actually going to take this inverter outside. I'm going to plug it into a much bigger battery, and I'm going to plug it into my car. And I'm going to let it run for about 10 minutes. Now, the reason I really wanted to review this product is because it does have a GFCI plug on it. That means that it should be bonded. It should have a neutral ground bond. Now, if I'm not correct in that, please let me know in the comments. But I was able to charge my car before because I did buy one of those little neutral ground plugs from Amazon. And if you plug that into your inverter, it'll work. But this should not need that. So let's go ahead and grab a huge battery, take this inverter outside and plug it into my car and see if it will actually charge my car. Okay, well, I've got everything set up out here. As you can see, I have my SunFun Kits battery. It's a 275 amp battery. I did do a video of this battery charging this car previously, so I'll go ahead and put that up in the upper corner so you can watch that if you're interested. I've got that connected to my 2,000 watt Leesky inverter. I'm using these same cables that came with it. If you're actually going to do this for a permanent connection, make sure and have at least, well, I wouldn't say at least, make sure and have a fuse on your positive side. I would say probably 150 amp fuse. That way it protects these cables. But make sure and size your fuse according to what kind of cables that you use. And then I have it plugged in right here, and I have a nice thick extension cord because my Nissan charger doesn't have much of a long cord at all. So that's why I like to have this nice big extension cord. It's a 12.3 cord, so it can handle up to 25 amps. Okay, so when I plug this in, what I used to do, or what I had to do before it was I had to use this neutral ground bonding plug right here. And I'll go ahead and put this in the description along with all this other stuff, so that way you can click on the links. They're affiliate links, so I just wanted to throw that out there. But at least you can find out more information about all these items. But I would have to use this to make a neutral ground plug. If I didn't do that, the ready light on my car charger, it would flash green saying that there's a problem. But as soon as it was plugged into a neutral ground plug, it would stay green. So as soon as I plug this in, if it's a solid green, we are good. This GFCI is doing its job, and we're going to try to charge the car. If it's flashing green, then we know that this GFCI isn't doing what I thought it was going to do, and we'll go ahead and plug in the neutral ground plug and go ahead and test charging the car anyway. Okay, so here we go. Let's plug it in. All right, look at that. See that right there? Nice solid green light. And that is it being plugged directly into this inverter. So the GFCI, and it's a neutral ground plug, so everything is working exactly the way that it should. All right, now that we know that this will actually charge the car, let's go ahead and do it. Okay, let's plug it in. Let's go ahead and put up on the screen the SunFun Kids app so we can see what is being pulled from the battery as soon as we plug it in. And here we go. Let's go. All right, here we go. And you can see the fans automatically kick on. And it is showing that it's pulling 1320 to 1340 watts. So it looks like it goes up in increments of 20 watts. The battery is already reduced down to 11.4. And actually on the SunFun Kids app, it shows that the voltage of the battery is 12.15. And you can see that on here it's saying between 1320 and 1340. That's the amount of watts that are coming out. But in the SunFun Kids app, you can see that it's showing 1700 watts. So we're looking at a difference of, what, 380 watts from what this is giving the car to what is being taken out of the battery. You can see that the load up here, it's at 2 bars. So I'm guessing there's probably 4 bars altogether. This shows that the battery is already at half. So that really does show that that it's judging it by the voltage of the battery, which is common for inverters. Because on the SunFun Kids app, the stated charge is actually in the high 80s. It's definitely nowhere near 50%. These conductors are they're starting to get a little bit warm. The fan is definitely on, but it's definitely doing it. I think that's super cool. The charger is showing that solid green light and that there is power going to the car. So everything here is perfect. There's no fault. And so this cable is staying nice and cool. I wasn't expecting it to do anything different. All right, well, I'm gonna go ahead and let this setup run. I'm gonna let it run for like 10 minutes just to make sure that it doesn't have any issues at all. And I'll let you know what the results are. All right, well, it's been about 10 minutes and this is running just fine. Let's go ahead and feel the cables, see if there's a bunch of hot air blowing out of the inverter. Let's just check it out and see what's up. Okay, on the inverter, it still shows that it's pushing, it's pushing about 1,320 watts out of the inverter. The fans in the back have been running the entire time, and the air blowing out of them it's warm, but it's by no means hot. These cables are pretty warm. I would not use these cables if I were actually going to do this in the long term. I would definitely have a fuse on here, and I would size up to at least a 0 gauge or 1/0 gauge cable in order to actually power this load. Because if you look at the SunFun Kits app, let's go ahead and pull it up. If you look at the app, it's pulling 1,700 watts out of that battery. That's 140 amps. So those cables are probably, they're probably reaching their limit on what you should really use them for. But overall, this inverter has worked flawlessly. It has a GFCI outlet on it, so you can use it with sensitive equipment, especially like car chargers that need a neutral ground connection. I think that's called it needs to be bonded. The ground and the neutral need to be bonded, and this inverter does have that. I would say it's very solid construction. The fans are nice and cool. I mean, they're running right now. I'm sure you could probably hear that, but it's not loud by any means. And just touching the inverter, I mean, it's a bit warm in the back. The front is nice and cool. But I must say that this inverter is doing exactly what you would buy it for. It is pushing a solid, 1,500 watts out of it, and it's not having any issues whatsoever. It's charging my Nissan, and my Nissan does not know the difference between this inverter and the house outlet. So that's exactly what you want. All right, so if you have any questions about the Leesky 2,000 watt pure sine wave inverter with GFCI outlets, please leave them in the comments and I will get back to you as soon as I can. Thank you so much for watching this video, and you all have a good night. Bye-bye.